Hey guys, Bukulate here. Like I said, I was going to bring you a video today, and here I am. Uh, yeah, the solar wind event that we were talking about is now here. It's just starting just a few hours ago. Um, Pretty much right on time. Maybe, yeah, well, actually, yeah. I said about the end of the day on, Friday into Saturday morning, and that's pretty much what it is. So it's just starting. If you look at this right here, guys, you got your wind speed at 665 right there, and the geomagnetic storm level right now is at G1. Okay, so what does that mean? Well, we'll go down here and look. Um, Something else I'm going to point out: this solar X-ray flux, real quick here, guys. See these little breaks, and I didn't know what they were exactly until it was a while back when I finally figured it out. But what that is it goes into like what they call an eclipse season. This satellite does, and it's the moon passing in front of the satellite in the sun. Okay, um, where they're getting this data from. So whenever that happens, the break in the data happens. So that's why you see that. Just to point that out. Now, same thing there too on that one. Okay, whenever you see those blocks out like that, typically that's what's going on. Sometimes they go down for safe mode and all that stuff too, but right there, especially when you see them in pretty sequential, evenly spaced time differences there, pretty good pattern there. You can pretty much bet that's a eclipse season on that particular satellite. So anyway, here's the geomagnetic storm level. Okay, the KP's at a 5 right now. I do look for that to go up. Okay, I was talking about this yesterday. I do think that this is going to be a longer event than it is going to be a shorter one. The past few ones we had that hung around for a while, they didn't stay in storm level very long. They would drop out of storm level and go back up like little pulses. And we see that often also. But this event here, and I'll show you the models here in a minute, what we're seeing this time is a more continuous flow. Not so much the wave patterns that we've been seeing for the past few months when we get these storms. And I think that has something to do with the size of the actual coronal hole itself. It kind of passed when it was Earth facing, okay, because we got to keep that in mind. 3 days ago is when this thing was Earth facing on the sun, on the satellite pictures. That's how long it took that energy to get here, basically. That's a rough estimate. I could do the math and figure out exactly, but don't need to because it's here. But what I'm saying is that instead of seeing the waves that we were seeing, like the really high dense material waves of charged particles, okay, from the solar wind stream itself, you can see the waves coming in. Now this time it's more of a consistent wind, okay. Now I guess you could kind of compare that to like a hurricane to a tornado, I guess, because a tornado is pretty much, you could be like a gust of wind, and a hurricane has sustained winds. Okay, and that's what I'm talking about here. But anyway, as you can see, we've been at G1 storm level. Okay, that's what that is over there. It's geomagnetic storm level. The KP, that's the index here. Okay, the KP is actually at a 5. They're basically telling you the same thing. It's just the vocabulary is different in an exact way there. So, but anyway, we'll move on down here. There's a couple interesting things I want to point out, and it's actually kind of a neat thing. Well, first off, we'll talk about this real quick. Okay, this is the ACE. I show this a lot. You guys know that. Now, when we have these events that we're having right now, the solar wind stream events, it's typical to see the phi angle go all crazy. All right, it just does. And again, I'm going to be speaking about that. I'm still putting that together. I know it's been about a month or so since I started mentioning that, but I want to make sure I get it right before I bring it to you guys, okay? I don't want to try to explain something to you guys that I don't fully understand myself yet. So, but anyway, you can see how the density here, the density here is like all over the place. Okay, now you hear me talk about popcorn all the time. Well, that's popcorn, okay, because it's fluctuating. in a pretty massive way, okay? Each one of those dots is a data point. So when we see like a continuous line, that means that the density's staying pretty consistent. Well, this right here definitely is telling you, hey, it's not consistent. All right, something else I'll say real quick. From here to here is 10 units. Just think of it that way, 10 units. Now from here to here is 90 units. So you have to keep that in mind when you're looking at these graphs. So a data point here to there would be 10 in difference, okay? And a data point from, say, here to up here would be 90, okay? So you got to keep that in mind when you're looking at these things, all right? That is pretty important because it could be a little bit more dramatic or drastic change there than what you're actually seeing. Now, you see the solar wind speed in yellow. Now, when the solar wind speed goes up, typically the density comes down. That's a natural thing. That's typically what happens, okay? And obviously, that's what's going on with this event. So, now, if you see them both moving up at the same time, we're going to take a hit. That's a fact, okay? Because that means the speed is fast, and it also means the density's up. So, it's a heavier ball getting thrown at us at the same exact speed. So, that's why we get hit harder when they both go up at the same time. But this is typical for what we see. So, anyway, we'll show you this one. This is just the predictive and the forecasted model and the historic model, okay, at the same time. It's the NLIL. Now, I've shown this a bunch of times. We're about right here, right now, as far as the timestamp. So what happened behind there is actually history. They know that to be fact. That's what their data points gave them. And they're trying to forecast 5 days out in advance. Okay, that's what this model does. So you can kind of gauge where you're going to be. Now, I can tell you right now that this graph, the forecasting part of it, gets changed a lot. Okay, they update this about every day, if not twice a day. So what I'm saying is that if you see something here, you might want to come back and check it again in a day because it's probably changed. It's very much like a local on the 8th weather forecast from the Weather Channel. You know, you look at it today and it says, hey, 50% chance of rain tomorrow or 2 days from now. And then you look at it tomorrow and it says 0% chance, right? I mean, it's a forecast. It's a model. They're trying to take data and forecast out what's actually going to happen. And, you know, they're getting better at it, but it's not perfect. And it's the same thing with this. This is space weather, right? So, as we move on, I do want to show you this, okay? This is the same thing, guys. It's just a different graph. It's telling you the same exact information, okay? It's the KP index. They got different colors that they use. Obviously, you see the little breaks and stuff on the electron flux there also. Pretty much the same data. Now, this right here I think is neat. Okay, this is the aurora. This is one of those neat things about having a solar storm. Okay, the solar storms bring the northern lights. And they also bring, well, I guess we could call them southern lights, but I think they call them Australian lights or something like that. They have a different name for them in the southern hemisphere. But they see those things too down there. So when you start talking about this aurora forecast, it's the northern lights. What this graph is doing is it's showing you they're trying to predict the percentage of the chance of seeing these northern lights. Okay? And if you watch this typically just stays really light green. You're going to see this thing get into the red in some instances here. See that? So wherever you see that red, you can guarantee they're going to see some northern lights right there. Okay? So, you know, and sometimes they get down on what they call lower latitudes. And what that means is here in the northern hemisphere, a lower latitude would be closer to the equator. Okay? So that's what that means, if everybody wanted to know that. But anyway, I'm going to pause for a second. All right, guys, I got you back here. This is ISWA. Okay, this is the Magnetosphere models. I'm going to show you guys the ones with the solar wind speed and our actual magnetosphere model here. Okay. Again, okay, we're getting a solar storm, so we're going to see some hits, okay? It's not unusual, all right? Now, why do we talk about hits in an unusual way on like a day-to-day basis sometimes? Well, because if there's not a solar event happening, then it has to be coming from somewhere else. And that's why we talk about it, okay? Now, so even some of the stuff that we see every just like a little quick hit, sometimes that does actually come from the sun, okay? But when we can't take it back to the sun, we have to, you know, explore other options. But anyway, I'm going to go ahead and run this through. What I've done is I booted up this model twice, and I went back because it only lets you see 300 captures behind. So basically, we're going to be able to see 600. So I'll go down here and look at the second one here in a minute after we look at this one first. Okay, because I wanted you guys to see it. So I'm just going to use the slide bar. And again, like I said, guys, obviously it's starting right there. I mean, we're starting to see stuff. See us compress. Now, you guys have heard me say that a lot. We get compression, and then it rapidly expands back out. That's us pushing back. Okay, that's a normal thing. And again, typically that energy there in the back that you see, that is not coming from a source behind us. And I've explained this before, okay, because the sun's over here. A lot of times what happens is we get hit in the front, right? Well, we have a thing that happens here. It hits us, and then it actually rebounds back from behind. You can see it happening. That's exactly what happens most of the time, and that's why we see this, what we call backside pressure. Okay, that word's been used a lot, but it's not coming from a source behind us on a normal basis. Now, can we get hits from something from behind us? Absolutely. Okay. Now, is it always that way? No. Most of the time when we do see that energy, it's coming from the front side first. It's just it's getting sucked back around, and it's creating that pressure. Okay. Not to mention that I really do think that we act as a capacitor sometimes. And what a capacitor does is it stores energy as it's given to it, and then when it can't hold it anymore, it releases it. Okay, anybody that's worked on machines before, as humans, we've been, you know, smart enough to understand that, and we use it in our machinery, and we store that energy there, and we've learned how to discharge it when we need it. Okay, but the Earth can't do that. The Earth discharges it when it has to, or if it's been, you know, influenced by something else to make it discharge. I do think we get a lot of this energy comes in, and it gets into our atmosphere, gets absorbed into the crust, and increases our earthquake risks. Plus, you know, I do think at some point, sometimes we kind of, I don't want to call it like an earth ejection or anything like that, but it's kind of what it is. I'm not really sure if that's exactly what's going on with that, but we do see that sometimes. And I showed it, you know, that I made that video the other day and yesterday showing that anomaly that happened. That was really strange. It happened up in here, and it blew out that way, right? So, I mean, there's a lot of stuff that we just simply have to figure out. That not anybody can't give us any really good information on it. There's explanations out there, but some of them are just like, what? Really? That's what you're going to blame that on? That kind of thing. So, but there are also good ones out there too. But anyway, as you can see, this is the storm that's hitting us right now. Okay, we get hit, rapid expansion. Okay, and what I want you to notice is you're not seeing a bunch of waves. You're seeing the consistent pressure. See how we compressed and kind of stayed there? We're not really expanding out very often. Now we do some. Okay, now something here too. You see that? Now we got hit right there, right? Now, right there. Right, where is that? Right there. You know, we see that little contortion in our shield line sometimes, especially when we have these storms like this. But when I showed you guys that crazy anomaly, you remember how it was contorting a lot? Well, it looks kind of similar, like it was trying to do it again. Okay, now it didn't do it all the way, but as you can tell, look at this. Okay, this little bulge out is a direct response to that. Okay, because it doesn't look like that on any other part of the model. So those two are kind of tied together. Now, I don't know what's causing that, but it's there. It's an observation. So we'll just pull this through, show it to you. Okay, see how we push back, we get hit over and over and over again. Typical solar storm, okay? What is different about this solar storm than what we've been seeing? I've already addressed that, right? It's a more consistent flow of wind, solar wind. It's not wind how you would think going outside and your hair blowing in it. It's just charged particles moving at a certain speed. That's what the solar wind basically is. Okay, now, also on these, when you're looking at this graph here, remember I was showing you how it's kind of crazy how we've been seeing these up and down differences, looking different on the top than the bottom. Because if we're getting hit at the same strength across, coming from the sun over here, theoretically the top part of this graph should look very, very similar to the bottom. And it does look similar, but we're seeing these little, you know, either on the bottom or the top, like it gets moved. I don't know if that's a complete normal thing or if it's something that's whatever, but. And also, if you guys are looking at this, here's the speed, wind speed itself. And I think I've seen like a 6 or a 700. I haven't seen anything much bigger than that yet. Well, was that a 9? There's a 7. And I think I've seen a 9 in there. Okay, now see, this is what I'm talking about right here, how it's more consistent. I'm going to stop it right there. Okay. These, if you look right in here, see how you're seeing these like this? Okay, those are basically little waves of energy, but they're close enough together that it's giving us more of a constant looking flow of solar wind. Okay, so when our shields get hit, we're not getting that break in between waves. It's staying constant on us. So our shield's going to compress and it's going to stay there for a longer period of time. Now, is that going to cause it to get weaker or cause weak spots in it? More stuff going to get through? I do think more stuff's going to get through because it's a constant barrage. All right, now is it going to cause big problems? I don't know. You know, if we get into like a G3 level storm, we can see power stuff going on, satellite disruptions. We've already seen on these tools how they go into safe mode at G1 or even lower, just like an active level, like a KP of 4. Because a KP of 5 is a G1 storm. So, you know, sometimes we see stuff like that. So, but I wanted to point that out because this is more of a consistent flow than what we've been seeing as of late. Now, there's some waves. You see those waves? But they're still real close to each other. Okay, and they're not letting up. That's what I want to point out. See, there it went again. See those little, okay? This is not stopping. And this right here was my point, because that coronal hole was so wide that we're going to have a continued, okay, now I want to show you guys something here too. Look at the timestamp here. Oops. It says 1447, right? And look at the capture there. Now, the very next capture, it's going to change like really drastically on the whole graph. See that? Look at the timestamp. 2243. All right. So, that was hours difference. Basically 6 hours difference. The tool went down for 6 hours right there. Okay. They kind of sneak that in every once in a while. I see this happen quite a bit. And usually it stays down for like 20 minutes or something and comes right back up. But that was a 6 hour differential there. But, okay, so we'll go down here and we'll check this out real quick. Okay, we'll look at this one first. This is the one that's most current. Pause it. Okay, now, sorry about that, guys. So we'll run this through. I don't anticipate seeing much difference from what we just seen. It is rotating there a little bit. We are still continuously getting these winds. Okay, you're seeing it bounce and, you know, rebound and compress, and it's there's that massive energy, what looks like to be massive energy on the backside. And again, that's not coming from the back, guys. That's actually coming from the front. All right, I just want to point that out. And I also want to say again, just to clarify, that I'm not saying that we can't get stuff from behind us, because we most certainly can, especially like cosmic rays and stuff like that. Okay, so, you know, when I say that this is coming from the front, I don't say that unless I actually think that, hey, we're getting hit from the front from the solar wind, and it's kind of, you know, reverbing back around and getting us on the backside also. Something else that comes into play, guys, this is a two-dimensional model. All right, what this isn't showing you, you're looking at a two-dimensional model, you're thinking that it's like a video game, right? And you're walking across the map on a video game. Well, that's not how life actually is. It's three-dimensional. So there's a top, a bottom, there's a depth, there's a width, all that, okay? So when we see that pressure on the back side, it actually could be, now I'm going to try to explain this the best I can. This energy hits in the front and it actually goes over top of us. And we see that on the backside. Okay, that's a possibility also. Okay, so it's hard to look at this in a three-dimensional way. I get it. But we have to really try to do so because that's what we live in, right? So anyway, we'll do this real quick. Okay, and again, you're not going to see like anything that we wouldn't be expecting during a solar storm. Okay, I mean, it's pretty much what I'm trying to say here. I'm going to pause. All right, guys, I got you over at USGS. Okay, this is the earthquake thing again. Okay, earthquakes have not slowed down. All right, remember me saying in my video yesterday, we've already exceeded our normal 6+ earthquakes for the month. Well, there's more already. So, anyway, we're going to go ahead and go through this. Plus, we got some earthquakes in some weird spots today. We actually had 2 earthquakes today in the Midwest of the United States around the New Madrid Fault. Now, that is a fault, and we do get earthquakes on it sometimes, but not very often. And it happened in Missouri, and they were upwards of a 3. One of them was. That's pretty decent size for that area, is what I'm trying to say. Okay, there's one in Yemen. That isn't so out of the ordinary. But then you got a 5.8 Easter Island. Okay. There's another one in New Zealand at 5. There's a 6 down here I'm going to show you right there. Okay, that's in New Zealand. Again, only 35 kilometers deep. Now, that's not 10 kilometers deep, shallow. That's 35 kilometers deep. Okay? It's a little deeper, but it's still not really extremely deep like we see some in the 3 to 4 to 500 kilometer deep. Okay? So, there's more. Okay? China. Alaska. There's those ones in Missouri. Okay, right there, 3.3. What I'm going to do is I'm going to show you guys something here real quick also. Okay, if you click on these on USGS, and it'll give you, if you click that little blue box I just did, it takes you to this. Okay, it gives you the option to go look at a interactive map, and it'll show you exactly where it's at, regional information, and then if you scroll down, it actually has a thing here. I think you can report if you felt it or not. Then it says felt report, tell us, right there on the left, and then it says did you feel it? Okay, it's an internet intensity map. Now you can view nearby seismicity, the origin. It shows you right there on the left, and sometimes it'll show you like a damage range or the probability of damage or loss of life and stuff. So if you guys just click on that, you can get to all that information just by clicking once. Okay, here over at USGS. Now, is it accurate? You know, that's always questionable when we're talking about this agency here. Okay, we know that there's some stuff around that. Just ask Dutch Sense, he'll tell you. Ask Scott, he'll tell you. Who else tries to? Oh, BP Earthwatch, Ben Davis, all those guys. I mean, they do the earthquake thing, and Terrell, Blackstar. All these guys do all the earthquake stuff, and I guarantee you that, yeah, I don't know that they agree with what's going on with this. But we don't have much of a choice. You know, we can look at the European agencies and stuff like that. They tend to come in at higher seismicity, higher magnitudes. Okay, they don't tend to bring them down as low as what the USGS does. Is it them just an attempt to do whatever to try to lessen the shock of it, to try to get people to think that we're not having these big, huge earthquakes as often as we are? Or is it just them, just trying to, I don't know what they're trying to do, to be honest with you. All I know is it doesn't seem right on the surface. And if you go ask those guys and watch their channels and all that, you're going to see, okay? And, you guys make up your own mind on that. But I do know that, when we see these things, there was an earthquake. But, the magnitude is what we're talking about here. And we've actually seen times where they've actually taken a whole earthquake off of this thing. For what reason? I don't know. Nowadays, in today's world, I guarantee you, because I got some of my stuff set up to, like when I look at some of these graphs and these models, it automatically records it as soon as I click on it. Because I've not did that in the past and went back to go look at it again, and it was gone. So I don't let that happen anymore. I keep my recorder always booted up. That way when I see something, I immediately start recording. That way at least I have that data. Anyway, here you go. 5.8 Easter Island, that was almost a 6. Another 5 in New Zealand. I mean, there's a 6 right there, and in New Zealand, that one, that's the one I just showed you guys. Going over the same information. Anyway, as you see here, guys, this stuff ain't slowing down. So, yeah. I am going to end the video here, guys. I did a model update. Hope you guys enjoyed it. I'll come back with some more updates. I will be bringing you guys some more stuff here. We're going to keep an eye on this thing. I do look for the geomagnetic storm level to go up some, at least to like a G2. Just because I think it's going to be more of an event than what's going on. I think that the length of the event may allow the storm level to come up another number or two. So we'll see. It may not happen, but that's just kind of what I'm seeing. I do think that for the most part, we're probably going to see a G2 at the very least. Now, if we get to a G3, I hope we don't. We don't really want to see things that high. But the auroras are going to be great. We're going to see some great aurora photography come out of this. I guarantee it. I'm sure they're all over it because they haven't had too many storms to go after this year. So, but anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid. Okay, guys, one more thing here, guys. Sorry about that. I went back and looked at the graph here. It just updated, and it looks like that we may be having a lull point in this storm. Looks like it might have bumped down a little bit there for a minute. It may stay there. I hope it does, guys. I hope it just got to this G1 and stays that way. But I do think that this storm's going to last a little bit longer than what. Well, basically, what I'm saying is, don't get like crazy thinking that this is going to stop like just one little smack and we're done. I think this event's going to last a little bit longer. Reason being, that coronal hole stayed Earth-facing for multiple hours, longer than what this is showing. Okay? So, we can still see a lull. It'll probably come back up. My guess is it's going to come back up. That's just my guess. If I'm wrong, I'm wrong. But that's what I see right now. But I did want to mention something, too. I want you guys' opinion on something. I thought about starting to do some of these in like the premiere mode on YouTube. That way I can be in the chat with you guys and we can kind of talk back and forth that way. If you guys want, have questions or what have you. If you guys think you would want to do something like that or watch it as I'm doing like that, let me know. Give me a yes or no on that. And that way, if you guys want to do it that way, we can. Not every video, but at least like to try to do it once or twice a week. That way we can kind of communicate. And you know, if you guys have questions, I could try to answer them or point you over to Scott or whoever else might have the information, and we'll try to figure it out. So, but anyway, guys, God bless. Shoe saves, and you can drink this Kool-Aid.
Down the Gorky Park, listening to the wind of change. An August summer night, soldiers passing by, listening to the wind of change. Closing in, and did you ever think that we could be so close, like brothers? The future's in the air, I can feel it everywhere, blowing with the wind of change. Children of tomorrow dream away in the wind of change. Walking down the street, distant memories are buried in the past forever. Down to Gorky Park, listening to the wind of change. Take me to the magic of the moment on a glory night, where the children of tomorrow share their dreams with you and me. Take me to the magic of the moment on a glory night, where the children of tomorrow dream away in the wind of change. The wind of change blows straight into the face of time, like a storm wind that will ring the freedom bell for peace of mind. Let your body like I sing, what my guitar wants to sing. Children of tomorrow dream away in the wind of change. The men of power are losing control by the hour. This is the time, this is the place, so we look for the future. There's not much left to go around. Tell me why this is a land of confusion. This is the world we live in, and these are the hands we'll give. You tell me let's start trying to make it a place worth living in. I remember when the sun was shining, and the stars were bright all through the night, and the sound of your laughter as I held you tight so long ago. I will be coming home tonight. My generation will put it right. We're not just making promises that we know we'll never keep. Too many men, there's too many people, thinking too many problems, and not much love to go around. Can't you see this is a land of confusion? Now this is the world we live in, and these are the hands we're giving. You tell me let's start trying to make it a place worth fighting for. This is the world we live in, and these are the names we're giving. Stand up and let's start showing just where our lives are going to. Wake up in the morning and I raise my weary head. I've got an old coat for a pillow, and the earth was last night's bed. I don't know where I'm going, only God knows where I've been. I'm a devil on the run, a six-gun lover, a candle in the wind. Yeah! We were brought into this world where they say you're born to sin. Well, at least they gave me something I didn't have to steal or have to win. Well, they tell me that I'm wanted. Yeah, I'm a wanted man. seen it shot down. I've seen it dying thing shot down in a blaze of glory. Take me now, but know the truth. 'Cause I'm going down in a blaze of glory. Lord, I never knew first, but I do first blood. I'm the devil's son. Call me young. No, 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 no. Yeah! Each night I go to bed, I pray the Lord my soul to keep. No, I ain't looking for forgiveness, but before I'm 6 foot deep. Lord, I gotta ask a favor, and I hope you'll understand. 'Cause I've lived life to the fullest. Let this boy die like a man. Staring down a bullet, let me make my final stand.